Hello, pre-calc students, and welcome to the fourth day of section 5.5, which is about trigonometric equations. So far, we have covered topics 1 through 5, and today we will focus on number 6, which is using a calculator to solve trig equations. So, basically what we'll be looking at today is what do we do if the angle we're looking for isn't on the unit circle. So far all of our answers have been on the unit circle, so what happens when they aren't? Well, basically what we're going to do is we're going to use our calculator to get an approximate answer, which actually sounds a little more, or is a little more complicated than it sounds because your calculator is dumb. Your calculator is dumb because it only gives you one answer, and oftentimes we're looking for two answers. So we actually have to be smarter than our calculator and know how to find both answers. And here's how you do that. You first need to decide what quadrants your answers are going to be in. You then find the reference angle by using an inverse trig function of a positive ratio. You then take that reference angle and put that reference angle in the quadrants that you want. So let's take a look at what that looks like. Let's do the following. Now, if I was going to ignore those directions that I just told you to do, I would just do inverse tangent of 12.8044, and on my calculator, inverse tangent, second tan of 12.8044, and you'll notice there's my answer. Now that is an answer, but it's just one answer, and this answer is in radians, because my calculator is in radians, but there is another answer that my calculator did not find. That's why we need to first identify the quadrants that our answers will be in. So I think about tangent, and I think about, if you look at this number is a positive number, so I think about the quadrants in which tangent will be positive. All students take classes, so I am looking for a quadrant 1 and a quadrant 3 answer. Now, when I type this into my calculator does give me the quadrant 1 answer. So, when I do inverse tan of 12.8044, I get 1.4929, and that is my quadrant 1 answer. But I also want a quadrant 3 answer. So my quadrant 1 answer is 1.4929. But now how do I find my quadrant 3 answer? Well, the way I do that is by using reference angles. This angle right here is a positive quadrant 1 angle, and this is called the reference angle. And what you do is you take that reference angle and you put that reference angle in the other quadrant that you want. And again, reference angles, if you remember, are always made with the x-axis, never the y-axis. So I go from the x-axis down into quadrant 3. So basically, I have to know that that point right there is at pi, and then I'm moving this far from pi. So this angle right here is 1.4929 larger than pi. So to find where that angle is, I do pi plus 1.4929. I do pi plus my reference angle. And you type that into your calculator and get 4.6345. And I'm going to 4 decimal places with all these answers because the directions say to go to 4 decimal places. Make sure you're paying attention to and following the directions about rounding. 1.4929 is my first answer, and 4.6345 is my second answer. And there it is. Let's take a look at another example. What happens when this number is negative? Well, again, the first thing you need to do is decide what quadrants you're in. So cosine, I'm looking for cosine to be negative. Let's see, that's where cosine's positive, which means cosine's negative there and there, which means I want a quadrant 2 answer, and I want a quadrant 3 answer. Now, if I solve this equation, I do inverse cosine, negative 0.4317. And if you follow my directions that I gave you, instead of typing this in, you're going to make that number positive and type that in instead. And when you do that, you get inverse cosine of 0.4317, and you get that answer right there. 1.1244. And this angle is not either one of these two angles that I actually want. This angle is a quadrant 1 angle because it's between 0 and pi over 2. It would be between 0 and pi over 2. 1.12 is less than pi over 2, and you can use your calculator to approximate those if you want. This, however, the reason I did this then, even though it's not an answer, is because this is the reference angle. And what I then do is I put that reference angle in quadrant 2 and quadrant 3 to get my answer. So basically both of these are going to go from this same point pi, but quadrant 2 will be that much less than pi, and quadrant 3 will be that much more than pi. So I put my reference angle right here. So I move that far below pi to get my quadrant 2 answer, and I move that far above pi to get my quadrant 3 answer. And the calculations that you do for those to get your quadrant 2 answer would be pi minus 1.1244, and to get your quadrant 3 answer, you would do pi plus 1.1244. And you can use your calculator to get that that is 2.0172, and this answer is 4.2660. So our two solutions are that x equals 2.0172 or 4.2660. Now, if you ignore my method and my instructions, you instead might do the following. You instead might just take your calculator and just leave the negative sign there. What happens when you do that? Well, you can see that our calculator will actually give you one of these two answers. However, it does not give you the other one, and I don't know what you're going to do to find the other one. There are ways you could, but I think my method that I've shown you is easier to get both answers, because if you just trust your calculator, it'll only give you half your answers, which is not good enough. One more problem to look at, and basically what's going to happen here is all those things we've learned earlier in this chapter also still apply. So you might have to first solve your equation using some of the previous methods, and then your last step, instead of looking up an angle on a unit circle, will be to basically what we've just practiced. So let's take a look at what happens here. You'll notice this is a quadratic trig equation. So you can see that I've got a sine squared and a sine. So if you're following what I like to do, I like to substitute in a variable for my trig function. So I'm going to replace sine of x with a y, and I get y squared minus y minus 1 equals 0. I then factor this quadratic, and let's see, that's y and y, that's 1 and 1, and then 1y and 1y. Nope, negative, oh no. Oh geez. Oh gosh. Turns out that this is not factorable. If it's not factorable, what do? Well, it's still a quadratic equation, and we should know how to solve quadratic equations that aren't factorable. You've been doing this for quite a few years. You use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. When you simplify that, you get 1 plus or minus the square root of 5 over 2. But for our purposes, this one isn't on the unit circle, so I'm going to use my calculator to get decimal approximations for 1 plus square root 5 over 2, and that's 1.6180. And if I do 1 minus the square root of 5 over 2, I get negative 0.6180. So those are my two answers for y. So y equals 1.6180 is one of my answers, and y equals negative 0.6180 is another one of my answers. However, I still am trying to solve for x, which means I need to plug my trig function back in for y, and I get the following. And now I need to solve each of these equations by doing the inverse sign. And now you'll notice that that is definitely not a value on the unit circle, so I need to use the methods that we've been working on today. First thing I do is identify the quadrants. This is a positive number, and sign is positive in quadrants 1 and 2, so I'm looking for quadrant 1 and 2 angle. However, if you type this into your calculator will give you an error, and then you might notice that that number is more than 1, which is a problem. That means there are no answers here for this equation, which means this doesn't give me any answers. Then I go over here and I do the same thing. Sine is negative, and sine is negative in quadrants 2 and 3, which means 3 and 4, which means I want a quadrant 3 answer and a quadrant 4 answer. If you type this into your calculator, you actually will get an answer, and you will get 0.6662. You then need to take that angle and find your quadrant 3 and your quadrant 4 answers for that. So basically, what you need to do is you need to take that reference angle and go that far past pi, and then here you need to go that far below 2 pi. So to get this answer right here in quadrant 3, you would do pi plus 0.6662, pi plus your reference angle. And in quadrant 4, you do 2 pi minus your reference angle. And when you do that, you get 3.8078. 2 pi minus your reference angle is 5.6170, and those are your two answers. And that's it. When you're working on your homework, be careful of rounding. If the question says to round to 4 decimal places, you need to do that correctly. It will tell your answers wrong if you're off by a little bit, so be careful with all your rounding. And if you got questions, you know where to find me.